Alright, hello everybody, we're in section 6.4 and we're going to look at logarithmic functions. So the definition. A logarithmic function to the base a, where a is greater than 0 and a is not equal to 1, is denoted by y equals log, here this a is a subscript, so it's written little and down here, of x, and is defined by y equals log base a of x, if and only if x is equal to a to the y. So what this is saying is that logs are the inverse of exponential functions. So that was important. Remember, when we talk about exponential functions, they're one-to-one. So that means they had an inverse. Logs are that inverse. The domain of a logarithm is positive numbers only. So this is our most restrictive domain yet. Remember, with those even roots, you can take the square root of 0. With the domain of a logarithm, though, you can only input in positive things. So let's take a look at some properties. Okay, so properties. Domain is positive numbers only, range is everything. With these logarithms, you have an x-intercept at 1, 0, and there is no y-intercept. Vertical asymptote at x equals 0, graph is smooth and continuous. It's decreasing if your base is between 0 and 1, and it's increasing if your base is greater than 1. And it's a one-to-one function. It's the inverse of the exponential. So you can kind of see this. If you compare these properties with those of exponential functions, they kind of look like opposites. And I have here an example of a graph where a is greater than 1. So these are all important properties that we have to know for logarithms. And now I just want to take a look at some basic properties, basic ideas with logarithms. Okay, so one important skill is going from one to the other. So I want to go from an exponential equation into a logarithm. Okay, so what you do is the base stays the same. So this is going to be base 3 because that's my base here. So I have log base 3. Now remember, inverses, the output is the input. So they're going to switch here. The input of the logarithm is going to be 12, and the output is going to be x. I'll have to take a look at another one. So example, if I have like 3 to the 18th power is x. Now let's not do 3. Let's do different. Let's do the number 5. 5 to the 18 is x, and I want to rewrite this as a logarithm. This would be log base 5 of x is 18. Okay, let's look at the other direction. Okay, so now I want to go from a logarithm into an exponential. So to do this, the base stays the same, so here's my a. Output turns into the exponent, input turns into the output, because they're inverses. Let's look at one more. Let's do log base 7 of 5 equals x. So if I want to put this in the exponential, it would be 7 to the x is 5. Okay, let's take a look at some common logarithms. Okay, common logarithms. One common one is base 10. So log base 10 is more commonly written with a capital L and no base down here. And this is usually on the calculator, but if you look at your calculator, you'll see that button. That means base 10 automatically. The other one is base e. So nobody writes this log and then writes the little e. Everybody's going to make fun of you. How it's written instead is ln, the natural log. And I bet you'll see this button on the calculator as well. ln, natural log, means base e. And e is a very important number, so natural log is very important as well. And those are your common logs. And I think that'll do it for logarithms.